I'd like to welcome you to the series of the Prague Talks on Digital Humanities, and thank you for joining us today for the first talk. The purpose of this series is to get more in depth in various directions in the field and to meet interested people who have a lot of things to say about the field. And so I'm very glad that we today have Kaspar Gubler from the University of Bern. As many of you might know Kaspar Gubler, I will be very brief about his CV. So Kaspar is now at the University of Bern, but before he studied at the University of Zurich, where he focused on history, constitutional law, and media studies. But at the first place, he is a medievalist. Kaspar is at present head of the digital development at the Repertorium Academicum Germanicum, which is commonly known as RAG. And he serves also as a co-director of the Repertorium Academicum, which is a broader project in a similar focus. He's also the head of the Spark project of the Swiss National Science Foundation, which concerns server-side data harmonization. Kaspar also works now on his habilitation with a project on digital reconstruction of transcultural communication spaces using the example of the University of Dole, which is end of 15th to beginning of the 17th century. He has many research interests, first of all, digital humanities, but also history of universities and knowledge. And he's a specialist in data modeling and data visualization. And that's one of the reasons why today he's going to give us a talk on digital humanities as data science, potentials and limits. So Kaspar, the floor is yours.
Yeah, hello everyone, and thank you very much for having me in this Prague Talks on Digital Humanities series. It's very kind of you. I'm looking very forward to present some thoughts about digital humanities as data science. So we will have some time, I think, after the talk for a little bit of exchange and discussions. So I won't make this too long. First, a couple of remarks about this digital humanities data science, and then I will show some concrete examples out of the Repertorium Academicum Germanicum, of the RAG, of this project. A bit of workflow, how we do it, and yeah, you will get really specific insights into this project, hopefully. So, yeah, I will not stress this too much, these definitions, what is digital humanities or what is data science. Digital humanities use and development of digital resources and tools, methods, and approaches to generate, explore, and answer research questions from source to data, information, and knowledge. For me, digital humanities is a super useful umbrella term, but it's not, for me personally, it's always my view here, it's not a discipline on its own, it's just a very helpful umbrella term. And data science is following an interdisciplinary approach, more focusing, of course, on computing, on algorithm, mathematics, statistics, in combination with expertise in the domain of research. And the combination of both is, or the benefit of it, in my opinion, is that data science supports digital humanities, because data science can help digital humanities to focus or to refocus on the quality of research data. If you begin to deal with data science and your data you have been collecting in your digital humanities projects, you will come to a point where you ask yourself, what kind of data do I have? What is the quality of this data? And so this is one of the most important points that I want to stress in this talk, that the data science really can help us to rethink about our data, about consistency, about incomplete data, about quality, etc. As you know, in digital humanities, digital archaeology, digital history, language studies, etc., we have the challenge of complex data. We're dealing with complex data that is often incomplete and heterogeneous. As you know, an example here, matriculation lists out of the matriculation books of University of Basel, 1460. And even this is quite a reliable source and not so incomplete and not so heterogeneous. It's really hard to get valuable information out of it through artificial intelligence, for example. So I'm coming straight to the point. Digital humanities is data science of smart data. I want to emphasize in this talk that maybe we could change the mindset from data and big data to smart data within digital humanities. And there, in the smart data approach, in my opinion, lies the potential. Complex data is smart data. And smart data, I see it as high quality data and verified data, plus embedded is data in the context of your research domain. So in the context of history, archaeology, language studies, and so on. And the limitations, I see it in the field of the big data, which is quite often more metadata. It's more superficial. And this big data has a lower quality and quite often, although in general, is not embedded in the context of a research domain. I'm stereotyping a bit, saying smart data and big data. There is an intersection, of course, but I want to stress that we could really refocus on saying, hey, we in the digital humanities, we are collecting smart data. We are able to deal with complex data. We are complex data information specialists or some kind of that. I will make examples then to show you what I mean specifically. I come up with the Iceberg model again. Sorry for that and for the design. It's not the big designer here, but maybe it helps to explain what I mean. It's the data on the top. You see the top of the iceberg. It's a raw data you collect with artificial intelligence, for example, with computing within your research project. Then you have the data on the top. But what you don't see in this data is the big context of your research domain. Generally, you don't see it. So the context what makes the data smart. It makes it interesting, as you know. And context means here you have read a lot of books within your research domain. You know a lot. You have studied a lot of sources with your human intelligence. And with your human intelligence, you can enrich then this data, this iceberg under the water. You can enrich the data and it becomes more quality. I'm stereotyping again a bit here. Big data and smart data. Big data is not only cannot be only generated through artificial intelligence, but normally it's the case. And so you would go with computing and artificial intelligence, collecting or generating your research data within your data science approach, but then you just miss the smart data part, the most interesting part, the stake of it. And you can only reach this part under the water with your human intelligence, as we will see in the example I will show out of the project of Repertorium Academicum Germanicum. So how to generate or collect such smart data? As said, in my opinion, artificial intelligence has really limitations here. And the potential lies in the human intelligence. And maybe you think, what is this guy talking about? He should talking about DH, about digital stuff, and he's only talking about human intelligence. It's not that I'm saying, shut down your computer or so and just work with your human intelligence, but more refocus on your research domain using digital tools and software for the analysis, but focusing really on your research domain, and don't let you dominate by artificial intelligence, by machine learning, by computing. It's more some kind of change of mindset, going back to smart data. And such a collection of research data only becomes valuable information through its interpretation in the context of research, for example, of historical research. If you just have the data, the raw data, it doesn't say much. We can make an example afterwards to show or to illustrate it. But if you enter by hand, for example, research data in your database, and then you do a lot of interpretation within the context, and then this raw data becomes information, and information of value. So you would say, okay, I'm collecting by hand, for example, in my research project, smart data, and this becomes information of value, smart information. It becomes knowledge of really quality, knowledge of value, and not like you're just grabbing out of the internet some kind of metadata. You have millions of triples of data, millions of data, a data mountain. But then, what about the quality? And some people are doing that and saying, yeah, we have some kind of knowledge graph then. But what is a knowledge graph? Nobody knows it really. So be very critical and very specific when it comes to what kind of data a project provides, or what kind of data a collection provides. So if you're asking yourself, you see a project out there in Digital Humanities, and then you can ask yourself, what kind of data does this project deal with? And you know these buzzwords like, we have metadata, we have linked open data out of the semantic web, or we have a data collection generated with machine learning. And then you should ask yourself, in my opinion, is this data really smart data, or is it more just big data? What's the meaning of it? Has it a context? What's this data really saying? Or it's not like they have a big collection, but it's on a superficial level. We had a project, not here, but there was a project that totally failed. And the project leader said to the sponsors, predicting the future with big data from the past is absolutely possible. And they did a lot of digitization, collecting 8 terabytes of data or so. But then this project crashed because they suddenly realized that they didn't use a proper way to store the metadata or to categorize this data. So to add a value, a real value to this data. And in my opinion, stuff like this, predicting the future with big data from the past, is just not possible because historical sources, as you know, are so diverse and incomplete that you cannot really extract patterns out of history for predicting the future. So I come back to this challenge of complexity of research data. It's the example of history, but in general in digital humanities, of course. And what is the best practice to generate or collect such smart data? And one example I will show you now in this talk is the project I've mentioned, and I worked for, I'm still working for it, the Repertorium Academicum Germanicum, RAG. This project runs for 20 years now, and it's a project working with a computer, but the core of it is human intelligence. So this project contains of a database with 60,000 scholars, as you can see here, the numbers, and 308,000 biographical observations located in 25,000 places. And it's about history of universities in the Middle Ages, especially in the old German Empire. And this data in this project, these 380,000 observations, have been collected by hand, by human intelligence, out of original, of primary sources, or out of printed sources. So every data entry, every data record represents something or represents the procedure of storing with your human intelligence some kind of information. And this makes the quality of data of this project. And many people are asking, yeah, but you could have done it today with artificial intelligence, just going through the sources, going through the texts and automatically extract information, putting it into the database. It is not possible, absolutely not, because as I mentioned, the sources are too complex, and dealing with this information, extracting it, is too complex. You must have a lot of knowledge within your research domain. Within your field of research, you must know a lot about history of universities and history of knowledge and so on. So it's not that easy still today. And this is why I compare it to traditional Czech Christmas tree decorations, this data, just to illustrate here, like this traditional Christmas tree decoration, this handmade decoration, has a value because it's handmade, it's unique, it's a lot of energy put into it and make it so unique and valuable. And research data of the RG is also handmade. So data collected by hand, but, and this is the clue, analyzed by the computer. So you have both worlds. So you have the best of both worlds. You have valuable data, and you have then the analysis function of software no-code we are using, and we'll look into it. And so you get the most out of it. Just a short remark where the project is heading to. This project is combining now personal knowledge. This means biographical data and written works of the people. This is a very interesting approach because most of the digital projects are doing neither the person or then are focusing on written works. But the combination of it makes it really interesting because we are looking at these persons, at these scholars, as knowledge carriers. They've studied at the universities, they acquire some knowledge, and then with their migration patterns, we say, okay, we see where this knowledge has been transferred to. With the mobility of these scholars, even if they not have written something, we assume that if they have been to a certain place after university, this knowledge must have been there with them. We cannot prove how intense the exchange of this knowledge was, but we know, okay, it was there available. And so the illustration here means in the first picture, the project started with prosopography, with the people, with groups of people. And then the book symbolizes, of course, the written works. And then the final picture is the combination of it. So a combination of prosopography and textual studies. And if you're in the textual studies, you know that there you can come in with artificial intelligence, with automated transcriptions, editing or annotating texts. And and this makes it interesting because then you have the two approaches from more the personal prosopography history, but also, for example, for us interesting to talk to people from the German studies, history of literature, for example, and to do this combination. Yeah, and as an example of this, at the beginning mentioned mindset of smart data in digital history, I will show you a bit the workflow of the Repertorium Academicum Germanicum. I will change then to the browser and we will have a short look into data model and then also to the data entry process, where we see, there is where the value comes in when the researcher thinks he sees something in the sources and then he types this information in. And with his interpretation within the context, it becomes valuable information. So from data to information, that's point 4. And then we can look a bit on the analysis function, what you're doing with this valuable data. Of course, even if you do visualizations and network analysis and stuff like that, you must interpret, as you know, the research results then. And always data science helps us to rethink also about this interpretation stuff, not only about the quality of the data, but what, so to speak, what have you with your visualization? What does this really mean? So the visualization itself has also a context that it's not really seen on the picture. There's context in your mind, all your experience in your field of research. And if we can combine at least this valuable information within the database, for example, in a visualization or in a network analysis, then we say, okay, we can acquire or we can detect some kind of knowledge through the connection of information. We can identify some knowledge patterns. And as I mentioned, if we're dealing with text, then of course, machine learning, automatic transcriptions and stuff like this, AI comes in and we use these tools, or we will use these tools. We are already doing, but we will use these tools, but always as a slave. And we are the master within our field of research, a field of history, of prosopography. So I switch now to the browser, and I put this link here with these scenarios in the chat. So if it's too boring, you just go a little bit surfing, and I'm going to explain what you see here then a little bit later. And now, as I said, we are logging into the backend of this project. Just few remarks about data model, data entry process, and about the points I mentioned before. You see here already 70,000 people in this database, and you see an Ereignis, which means an event, which means these mentioned observations going up to 400, 390,000 events, all recorded or stored by hand since 2002. And then you have these locations, and with person, event, and location, you cover all of this massive data. So these are the most important 3 categories, for example. You can 3 objects, object types. People who are working with no code already, they know exactly how this works. And if you're not familiar with it, it's quite easy. It's like a table in Excel. The person is a column, Ereignis is a column, and location is a column. It's super easy. And then you say that a person has a lot of events, points in life, and these events have or must be located in space and time. It's like as you know, in humanities we observe something, as in the basics. We observe something and then we describe it. That's what we do. And this Ereignis model, this event model, is just doing that. We're observing something in the sources, and then we, with the Ereignis here, we describe it, and we connect this Ereignis to a location. We say, okay, the location can be university, can be a city, can be a court, a princely court, can be a school. And then we connect it also to a person. So first we go to store the location and the date, of course. This Ereignis, this event is then stored in time and space. And then we connect it to a person. And this is the simple, straightforward data model, which I can highly recommend. It has been developed by famous Rainer Schwingers, the inventor of the ROG project. And because with this Ereignis, with this observation, you can cover everything, because as you know, in history, everything is an event, kind of. And yeah, this makes things a bit easy. But of course, you must have your rules, how to enter the data, how to enter such an event. And we cover with this event a couple of personal data, we cover study data, we cover activities, jobs, careers, and so on. And so if you have a research team, you must be very clear with these people and say, these are the rules how to enter the data, of course. And yeah, I go for person here, then you see how this is working. And we have down here now this list of events connected to a person, and it has a location, of course, here, and it has a date. Date and location are very, very important for your visualizations on maps, of course. And in your project, you must store somewhere geocoordinates for the University of Basel, for example, here. You can go to this point in your database where the geocoordinates are stored, and you see you have this point here. So if you start a project, don't use only names, but just go from the beginning storing, or just start with storing geocoordinates as well. It's very important. You can do it afterwards, but this will be a lot of work. So, and
Kaspar, I'm sorry, can I interrupt you? Can you put it to full screen, your desktop? Yeah, thank you, great.
Oh, sorry, yeah. And, okay, and for this data entry process, just to see, make this a bit smaller here and down here, okay. How this works, we have here an original source, as you can see, and this is the matriculation list of the University of Basel of 1460. And if you, for example, use a software to transcribe it automatically, like Transcribus, which is very good software and super cool and super useful, then you come in with this machine learning, artificial intelligence aspect. And for example, this Laurentius-Krohn we saw before comes here out of the city of Schaffhausen. But you know that the software, this AI software, which is doing the automatic transcription, doesn't know that Schaffhausen here is really a town. You just have the raw data after the transcription. And you don't know if Kron is maybe money. No, it's not. It's the name of a person. And Laurentius, it's the first name. And then he's coming from he is in the Constantiensis Diocesis offici. And what does this mean? Officialis. So he is the highest jurist of the Bishop of Basel, Officialis Curiae Basiliensis, Bas. And he's a licentiatus in decretis, so a licentiatus in canonical law. And for the computer, as you know, it's super hard to know that. So he doesn't know anything when starting. And this is where your human intelligence must come in. And many projects do underestimate this effort. You can run through an original text automatic transcription, but afterwards there is a lot of hand work to be done with text tagging. You have to tell the system Schaffhausen, it's a city. Schaffhausen is the city where the Rhine Falls are in Switzerland, maybe you know it. And Laurentius Kohn is a person, and officia means the official. So it's a job. And it's the highest jurist, and so on. So there has been, you must come in with a lot of human intelligence, a lot of people tagging your raw data to make it a valuable information. As you can see here, we have already an addition of this matriculation list, and we're working as well, of course, with these additions as a great work done by Wackernagel, and adding here some really valuable information was what this Laurentius Kohn has been working as. He was mayor of city of Schaffhausen, for example, etc. But also here, if you're saying, okay, let the computer go through it here and let it extract the information for the computer, it's very hard to understand what this means. R.Wackernagel 2, 2, and so on. And here is a star and there is a cross, and it's super hard. And it doesn't really work to extract here information out of it. And so the RAG decided to do this by hand from the beginning. And as I mentioned a couple of times, this makes the data so valuable now. Okay. And one of the results is, for example, that you can, I'm just looking here for the right scenario. Not coming here, just a moment. Yeah. So that you can make out of the data now such cool and really interesting scenarios, bringing on the map here places of origin of students of universities of Vienna, the red one, and Krakow blue, and of course Prague, the oldest university within German Empire, founded 1348. And in the back you have, or in the background, you have here the dioceses drawn by the famous project Germania Sacra. And then you can detect, of course, here around the diocese border, no one's coming really to Vienna, or just a couple of people. And so we go into the analysis of data showing here the University of Prague, geographical origins of students at University of Prague, and see that Prague, especially, of course, in the 14th century, covers the whole of Europe, or attracts the whole of Europe. But then, of course, we know that the history of University of Prague, it changed in the 15th century, but you see a lot of attraction within the diocese here of Prague, for example. And as I stressed before, this is all valuable data. And so this makes this visualization also very valuable in the end. And you see that each university has its own pattern here, like Krakow And especially Vienna reaching out from the east here, from also you can see the border of the German Empire, but reaching out here far in the west, and so Vienna has its own profile as the other universities. So this is just to give a small insight of what you of one approach how to deal with data science in digital history, for example. And just to finish it, I mentioned these scenarios here, and this is data prepared out of the database here. So directly and dynamically, if I change here in the backend something, then it changes also here in the scenarios. So this is connected, backend and frontend, and this is the public website. And just play around, for example, with the University of Prague, and you see the different categories of artists, of jurists, of physicians, and of theologians, and of noble people here. And then you click on such a cutout of the data and go to map, and it visualizes dynamically. So it's loading directly from the database, the fresh data, so to speak. And you see then here the universities. You can fade this out here. You can also fade out the diocese draw by the Germania Sacra. And then you can just fade in, fade out what you're interested in. You see geographical origin here, but you see also the study data here of noble scholars attending the University of Prague. You can add universities again, and if something like this happens, you're flexible to draw here your individual map with no code. So, yeah. I think that I will stop right here, and I'm waiting for your questions. Thank you very much for your attention. And yeah, try to stop the screen sharing here. Yeah, thank you.
Thank you. Thank you very much, Kaspar. That was super interesting. I have a lot of questions.
Okay.
But I think that now is the time for the others to ask questions or start a discussion. So who would like to ask the first question? You may just unmute yourself and ask a question. Okay, so it seems that people are shy.
Monica, Wednesday maybe. Or
right, Monica?
Yeah, no, she just made so. I like the Pope a bit. So.
Yeah, I was like, there's no reason.
Okay. Yeah.
Well, yeah, we could start a discussion.
Just go ahead. So I hope it's just one example.
Well, yeah. Well, one question will be about the interoperability with other database, and because of course, as you said, you're smart data, big data, right? And in parallel, we have there are other projects and ideas how they can join, or how we can benefit from experience, but also from the data. Yeah. So how?
Yeah, you're absolutely right. So this is a quite individual project here, but I was running this project about interoperability, this dynamic data ingestion, sponsored by the Swiss government, and we have been working a lot with these questions, interoperability. And for example, this software no-code provides a couple of methods or tools to make your data interoperable, but you could start a project, of course, using an ontology. And this is your responsibility. There are a lot of ontologies, and this is not so the problem. it's more a decision. But if I'm really honest, then a lot of historians, I know the history, the field of history, very good. They don't really care about ontology still today. So they saw the project and saying, oh, we don't need, or yeah, we want to avoid long discussions about ontology because, you know, ontology sometimes has a tendency to religion a bit. So what is the best ontology? We want to cover all. And this is, it's a bit canonical. And so I understand projects which just want to start. The problem in general, or just to finish it, in my opinion, is not the ontology, but it's just to store your data according to fixed rules. So to really check that it's not not heterogeneous. Yeah. And as you know, if you can store everything in the computer, if you're doing just the same thing every time, it can be absolutely wrong from the sense of content, but you can change it afterwards if it's really stored in a regular manner always. And what my experience is that many projects really don't care about it. Yeah.
Because they're scared, right? Historians are scared of technical issues.
A bit, but it's also, as I said, the sources are so diverse, it's really hard to connect. So really, a person is, okay, a person name is quite simple, super simple. But then if you go deeper into structured data, into details, this, for example, for the Middle Ages, is super... challenging. The universities are quite stable institutions, and especially in the German Empire, more or less same organized in same structures and manners and way or so. And this makes it much more easier than if you're dealing with correspondences, for example.
All right, thank you. And some other questions or remarks or further discussions?
Yeah, thank you for your very interesting presentation and the distinction between smart data and big data. And I have two questions. First of all, how do you treat the problem of certainty of the data? How can this be represented? For example, a certain event is certainly dated precisely, another event is inferred in a certain period, or I don't know, a name maybe of one person or of another. And the second question, based on Monica's question, doesn't this smart data, when it's finished, when it's published, become big data for another project? I mean, they just look at so much information, and it's just data for them.
Yeah. Okay. Yeah, the example of TRIPTIC-EU. So maybe you think, 500,000 is already big data. So, and maybe not, or it's smart big data or the big smart data. I don't know. It's I'm stereotyping a bit with it. And of course, you're absolutely right that if you publish this data and you don't have the context, it's also it's smart data can turn into big data in the sense of I've mentioned it. This so it's a very good argument, and you have to read a lot of books and go into this field of research to understand what this visualization is really meaning. And this is an interesting remark. So I've traveled a couple of years now around Europe to conferences presenting these visualizations. Always universities. Place of origin is the most popular thing I'm doing. But one person once asked, what is behind this colored dot? What does it represent? But it was only one person. A couple of conferences around Europe, really, a lot of people have seen it. Just visualize something today, and people are go like, oh, wow, this is it. And no one is asking what's behind your dot here. What is this? Is this one, or is two, or is a person, or what else? And I think we in digital humanities, or humanities in general, we have to learn this to be critical and critical visualization studies or whatever. It's like if you're dealing with your mobile phone. If you're in the opera, you turn it off. But maybe 10 years before you didn't. But now you learned that at the conference, I should turn it off. And so this is a process of learning, which I think is very interesting. And dealing with uncertainties, it's very popular now to discuss. And this is a problem. And we have incomplete sources. We have, as you know, and I'm a medievalist, I know this is not really complete. And the most straightforward approach is that you store your observation and you tag it like uncertain or probably or something like that, person probably, and so on and so on. And for example, but in no code, you have the possibility to store vague dates. So you can store as something like it could have happened 5 years before 1408. And this is very sophisticated. So especially dealing with dates is quite complicated, and you can do it with no code, and it takes this uncertainty then also into account if you do visualizations then. So this is from the part of the date, and from the part of locations, of course, it's also we just make a point on the map and say this is region of Poland, region of France, or and then you can color these dots differently, and you can make a legend and say, okay, fade in, fade out, the dots not certain, for example, like this. But we are not drawing areas, for example, saying this is region of, so we're just making dots. And in doubt, just make a dot with geo-coordinates and tag it as uncertain. So that you really also have the uncertain data on the map, and then fade it out, but not, oh no, I'm not certain, I'm not doing anything here, so I will not store geo-coordinates or so. And this is how we deal with that. And of course, we have, as you know, many challenges there. And we sometimes we just make a point and say, okay, this source is telling that. I'm not sure, but I just store it like this. The source is saying this and that. And then someone who wants to go deeper into the sources or searching for other information, he can do it. But we just provide here what we have.
Well, many thanks. So some further questions or comments? Well, I would have a question because the amount of data is really impressive. If I'm not wrong, I saw something around 4,100 data. I mean, metadata, pieces of metadata. Mm-hmm. So I'm wondering with how many people were inserting these data to the database, to the table, and verifying its contents and so on.
I assume you mean the scholars or the...
Yeah, I mean, how many people were involved in the data insertion?
Over the 20 years, a couple of research teams, 2 universities with, a team of 12 people, maybe. Okay, let's say a team of, 10 to 12 people working 20 years. So, and you have students and part-time students, and they come and go. And the new arrivals, you have to introduce them. These are rules, and rules of data entry change over time, and so on. And yeah, so data consistency is I forgot the term before. Data consistency is the most challenging point here, and it's only consistent here because you have these stable institutions. And you have these matriculation lists, especially for German universities. And it's a list with a name, as we saw, a name and a place of origin. And so this is quite valuable information for medieval sources. Then you have a person, and this person really existed, you can say, out of the source. And he was at university, and he came from a point. So you have 2 points and a person. And this is already a lot. Of certainty. But of course, some people say I'm coming from city of Prague, but they're not coming. They're coming from a small village, but they will not give you a correctly address because it's embarrassing coming from a small village. So they choose a bigger city, and we have all these cases, of course. Yeah.
Well. What came to my mind is that it could really get complicated with hiring students for this job, because students usually do not know exactly what's exactly going on, and it can lead to troubles. So basically, I'm just wondering if you had some issues with hiring students, or if it was if you were able to provide very good guidelines for data insertion. But I'm still wondering how it worked, because sometimes you need to do real research to find out the details, the metadata about a person.
Yeah, absolutely. You're absolutely right. So this process is, from the beginning, is a lot of effort you must put into tell the students what to do. And still now, today, still this week, student came. So we need a cheat sheet, or we need some more guidelines, and it's too complicated to store all these activities, and we must exchange more. And there was a bit of quite a discussion again. And so you must really invest a lot of time in teaching. And of course, there are problems, starting with easy cases and then going step by step. But in the end, it works. And students, they have a lot of fun, because they say, hey, I'm part of this big project. And you have one goal. And as you know, in project management, it's very important, or you have one aim, and everyone is heading for, we have to capture all the students out of for this university, and then we have to add this data. And so maybe it's just a short remark. The data is divided in 3 blocks: personal data, block 1, study data, block 2, and activities, block 3. And so this gives you some kind of orientation, also the students. You can say, okay, you're working now on the study data, and typing in a matriculation list, for example, is not so super complicated for the start. But you're absolutely right. You have put in a lot of effort.
Mm-hmm. Thank you. So who's next? Monica? You have to unmute yourself.
Just to continue the discussion was also, what about connection with researcher, right? I'm a researcher, I'm doing my research, I obtain some findings, some results. How dependently, or as an individual, can I share my research with you? Can I send my input? That will be, the idea is that a consortium of a researcher will bring some benefit for you, and have something like how I share. I find new authors and I would like them to be in your database. How should I proceed to get to send this information to you?
So the people are sending emails from time to time. And then you can get into contact, what you're doing, and maybe set up a Zoom meeting or so. And and then we have to explain, okay, this is our model. Not saying this is the best, but
just like a template or something that.
So, but it never happened because, but no, it happened so that we have researchers from external researchers and using the database in the backend and doing a bit of analysis. Of course, this is absolutely possible. The system is open here. But as you know, in digital humanities, digital history especially, it means also work. So the computer is not doing the work for you. And a lot of students come and say, okay, I can have a lot of sleep here now. The computer is writing my work, and then say, no, you must do data entry. You must rethink about data, about uncertainty. You must think about incompleteness and so on. They go, it looks like work, and and so we can provide this environment, but we have in University of Bern, we have a no-go-go installation, which means a multi-user platform, and there are a lot of students. I teach also the students how to use this, and there are a lot of students are active, and as you know, you have all kinds of students, and some of them are really strong and they really want to do something, and they log in and they enter data, and and the best case is if they have digital skills and enter data, and the worst case if they don't have digital skills but they want to enter data. And but so you can also provide an individual research domain within 5 minutes. It's the installation is very fast. But if you want to really, as a researcher, if you want to use this, and we are very open, very interested.
That's very good to know. So that was an offer, I guess.
I think so. I just, of course, we have capacity.
It's perfect. So Monica is saying something, but she's muted, so.
Sorry, I have a bad connection and I tried to slow down the thing. So I said we are working very much on individual authors, and always they are connected in universities in Vienna, not Vienna, Germany and things. And we might have things to share sometimes.
This is also sharing. For example, I can also share the data model. So within no-code, it's done in 5 minutes or so. I can export, import it via interface, via API, and then you have the whole of the data model just to have a look at it. It's very easy. It's in JSON, or you can also use it in other database system, of course, but it's within no-code exchanges makes it very easy. And then also exchange a bit of data or experience, and especially if you're working with texts. Fascinating. Someone in German studies is now reconstructing a library within no-code at University of Bern, a library of a scholar of 15th century. And the scholar also always makes some kind of annotations within his library. And look, vide book. And this project only stores now these references to other books, giving you some kind of impression what the scholar at this moment, when he references to other works, to his own, some kind of mind map of his view of his library or of his books. And this is very easily done with network analysis. But also there you have to enter the data manually, but it's quite sophisticated and flexible, so it's not taking really so much time, this data entry process.
To know that, because have similar situation right in Basel.
All right, so I guess that we still have time for a question or two. So Mihai?
Question. How much do you rely on software for data validation and quality assurance?
That's a super good question. Maybe I can share my screen again for not to make it here too long. But if you see here, the screen. Processes means this is automated text tagging based on filter queries, based on queries. So the data is queried here every night, and then based on my filter queries, look for all jurists. A jurist will be tagged as jurist, for example. Or if you set up a query saying, show me all wrong data, wrong dates entries, then overnight this process goes and marks it with a red flag. Also, this entry of a date is wrong, or this combination of the data is wrong. So this is the data-driven approach within no-code with these so-called reversals. This means after data entry process, you're running a couple of reversals on your data for data checks and see how, if this data is consistent. And if we look here in the, also in the public interface with this Laurentius Kron, I'm just showing you an example of such a reversal. And this here are all reversals here. The Fachgelehrter means he belongs to the category of, this is the big one, big category of artists. He joined the artist faculty, and he is a jurist. And Fachgelehrte Universität means he belongs to Universität Basel, to all of the scholars, to Vienna, all of the scholars, and he's a Vienna artist. And this is done automatically with this text tagging reversal function overnight. And and if you look here, I can click now on this jurist, on this category, on this automated generated category, and you see, he got 20,318 references. This means 20,000 jurists in the database. So this automated text tagging process helps you also browsing through your data. And if I'm searching here for someone and he's not a jurist, then maybe it was a wrong data entry. You could also color here these people, or you could color the wrong ones red, for example, and which is very helpful for detecting errors, of course. And and this also, these categories here give you really a super easy approach of data analysis, going a little bit into deeper, seeing 7,000 people are attending at University of Vienna. You can also then use the filter here to combine this and to say, for example, all people in Basel and at University of searching for all scholars in Basel and all scholars at University of Prague. And as you can see, you have here the OR statement. So it means you will have all of them. And then you can easily switch to the end statement, and it gives you the intersection of it. And you see there's not so much. It's only these two guys here. And then you go up here and you go deeper into data, and you see this scholar did quite a journey here to Rostock, Paris, Freiburg, and so on. And you can also here go deeper into data again with this so-called reversals, also for graduation degree, Magister Artium, and so on and so on. So you can use this to tag, but also to detect errors. Okay, maybe I can stop this, or you will stop the screen sharing again, or maybe you have
I'll do it.
Question.
That was very interesting. I would have another question concerning the data insertion. I'm wondering how we work, if these are the students who are putting the data directly into the database, or if they're providing some Word or Excel documents and then sending it to someone who is responsible for data insertion.
Yeah, in general, it's the best way that they really do it directly. So they're capable, and to say you are responsible what you're doing. It's published on the internet, but you have many possibilities to also to check and to say this user always has a red flag in his data record, and then you click on the green flag, but you have to check. But it's a lot of work. It doesn't really work. So if you have to check all the data records or data entries of 3 or 4 students, so yeah, you spend a day with it or so. So yeah, it's better to check data afterwards with these reversals. If you're really if you want to be on the safe side, you can make just one attribute to a person, for example, has to be checked, yeah, by someone or so, and will not be published. You have any kind of possibilities here, but it's really good if people are just directly entering data and
mm-hmm. All right, thank you. So are there some further questions or comments? It seems that no. So I think that we can thank again to Kaspar K.Gubler for giving us the interesting talk about his databases and his project and his views on the matter. So thanks so much, Kaspar. And thanks everyone for coming. I'll make a short advertisement as next time we will have Roman Blayer and Florian Zeilinger from Graz and from Munich will be speaking also about digital editions. So everyone is invited, and that will be our second Prague talk on digital humanities. It will take place on 25th of May at 2 p.m. So if you're interested, then join us, and we'll be sending once again the link for the registration at Twitter and elsewhere. So hopefully it will get to you. So thanks a lot. Thank you, Kaspar, again, and I hope that we'll be able to see each other next time.
In Prague, yeah.
Okay, Prague.
Hopefully,
right.
Hopefully.
Okay, so thank you and bye-bye.
Thank you. Bye.
Bye, thank you.